Hello everyone, we have came with yet another video of Public Service Commission examinations old question solution for the civil engineering. This video would be equally helpful for the bachelor level students of different universities, and it will be vital for the diploma level student as well. So watch the complete video. Before going through the old question solutions of Public Service Commission examinations in civil engineering branch, I want to add a note that great opportunities are not seen with your eyes, they are seen with your mind. So this is the line that I have taken from the book called The Rich Dad and Poor Dad by the Robert Kiyosaki. So we have been asked in the previous year Public Service Commission's examination that to calculate the stopping side distance on a graded highway for a design speed of 90 km per hour, the reaction time of the driver is 2 seconds and the coefficient of friction mu is equals to 0.35. So we have given a cases here. First is to when the grade is 3% descending, second is when the grade is 3% ascending, and when the grade is nil, that is when the road is flat, that is zero gradient. So here we need to calculate the stopping side distance on a graded highway having the design speed of 90 km per hour with the reaction time of the driver 2 seconds and the coefficient of friction 0.35, having the three cases as the gradient descending 3%, as gradient 3% ascending, and having the gradient 0, that is the flat road. So this stopping side distance is the minimum side distance available on a highway at any spot having sufficient length to enable the driver to stop a vehicle traveling at design speed safely without collision with any other obstruction. Stopping side distance is also known as non-passing or non-overtaking side distance. Stopping distance is one of the important measures in traffic engineering. It is the distance of vehicle travel from a point at which a situation is first perceived to the time the deceleration is complete. Drivers must have adequate time if they are suddenly respond to a situation. Thus, in highway design, side distance at least equals to the safe stopping distance should be provided. We will go through the solutions of this problem. So we need to calculate the stopping side distance, and we have known what is stopping side distance is. So stopping side distance is the combination of lag distance and the braking distance. So this lag distance is the distance traveled by the vehicle during the total reaction time, and the braking distance is the distance traveled by the vehicle after the application of brakes to a dead stop position, which is known as the braking distance. The lag distance is given by the formula velocity into the reaction time of the driver, and the braking distance is given by the formula v squared by 2g times nu plus minus n, where v is your design speed, g is the acceleration due to gravity in meter per second square, and n is the grade of the road. And this expression is, so you have velocity in this expression, and the velocity in this expression is in meter per second. So whenever you have to use this formula, you need to convert the velocity into the meter per second. So whenever you are given in the question that the velocity is in kilometer per hour, so you need to convert it into meter per second so as to use this formula for stopping side distance. But when you have to use the velocity in the kilometer per hour, then you can directly use this formula. SSD equals to 0.278 b into t plus b square by 254 nu plus mu plus n, where the symbols has their usual meanings, where b is the velocity in kmph, t is the reaction time of the driver, and this mu is the coefficient of friction, and n is the grade of the road. Okay, so whenever the braking efficiency of the brakes are given, you have to introduce a term known as braking efficiency. So in such a case, the stopping side distance would be given by the formula SSD equals to 0.278 b into t plus v square by 254 times mu plus n times the braking efficiency. So this is the formula when you are given the braking efficiency, when the velocity is given in kmph, when there is the n, the gradient of the road. So this is the formula you have to use. So you have to use accordingly. When you are given the braking efficiency, you can use this formula. So in this case, we are not given the braking efficiency, so we will simply use this formula. In the above formula, for the descending gradient, we need to use negative sign. So for the descending gradient, we use negative sign, as the component of gravity acts along the descending gradient and hence making the increase in the braking distance. And for the ascending gradient, we need to use the positive sign, as the braking distance is decreased, isn't it? So for the descending gradient, you will have a higher value of braking distance, and for the ascending gradient, the braking distance value would be lesser as compared to the braking distance you obtain in the descending gradient. So you have to remember that. So our first case is to determine the stopping side distance when the grade is 3% descending. Okay, so we have n equals to 3%, that is descending gradient, and we have the formula of stopping side distance 0.278 b into t plus b square by 254 mu plus minus the n. So we can easily substitute the value of the design velocity v in kmph here, that is equals to 90, and the value of the reaction time of the driver as 2 seconds. And one thing we need to remember, that this is a descending gradient, and in this formula we have to use negative sign, since we have stated previously that for the descending gradient we shall use negative sign, because the braking distance in the descending gradient will be higher because of the gravity component acting along the descending gradient. So the stopping side distance in the case first will come out to be 149.69 meters, having the lag distance of 50.04 and the braking distance of 99.65 meters. Our second case is to determine the stopping side distance when there is the ascending grade of 3%. So one thing we need to know, that for ascending gradient we shall use the positive sign here in the expression of SSD. So we just put the positive sign and find out that the lag distance as 50.04 and the braking distance as 83.93. So adding off, the total stopping side distance would come out to be 133.96 meters. So one thing we need to note here, that here the braking distance is always lesser as compared to the braking distance that we have obtained in the descending gradient. Okay, finally, we need to find the stopping side distance when there is flat gradient, that is 0 grade. So we have n equals to 0%, and if you substitute the above parameters in the formula of stopping side distance, we can easily find that the lagging distance will be 50.04 as found in the previous cases as well, and the braking distance will be changed because we have put the gradient, that is n equals to 0% here, and this comes out to be 91.11 as braking distance. So if you sum this, the total stopping side distance for the flat gradient comes out to be 141.15 meters. So at last we can finally conclude that for the descending gradient, the total side distance, that is total stopping side distance, should be required maximum, and for the ascending gradient, the total stopping side distance required shall be minimum, and for the zero gradient, the stopping side distance would be the value that is in between the ascending gradient and the descending gradient.
So friends, if you find this video as useful, you can like and share to your friends. And for such videos, stay tuned to this channel. Thank you. We will meet soon in another video.